Hello all, welcome to the Java tutorial. So in this one we are going to see about JVM architecture. Why we need JVM architecture? Because when we create a Java program, first it will execute in the compilation state and the next state it will be an execution state which will happen in the JVM. Okay. To understand about JVM architecture, we have to know first what is program. A program is nothing but a set of instructions. It's a completely set of instructions will be there. It is just a set of instructions, and the program is further divided into compilation state and the next one is execution state. So what is a compilation state? A compilation state is we check the programming rules, the checking of programming rules. Whereas in execution state, we will execute to generate output. Okay. In compilation state, C, C++ and Java languages use their compilers, whereas in execution state, C, C++ use compiler, whereas in Java it will use interpreter and compiler in execution state, which improves the performance of the program. Okay, this is for Java and this is for C and C++, whereas this is all use C, C++ and Java. Now we will see what is the difference between interpreter and compiler. Both are the translator. Interpreter and compiler. These both are translators. Which translate a high level programming to low level programming and a low level programming to high level programming. But compiler translate the total program. Compiler translate the total program, whereas interpreter it will translate line by line. So this is the main difference between interpreter and compiler. Okay. Now we'll define what is Java class. Java class is a collection of, as I said in a previous video, it is a collection of data, methods and void main. This is the definition of Java class. So we have seen what is data, we know what is data, we have seen what is method, that is a function, and now we'll define void main. A void main is the starting point. It's the starting point for executing the high level programs in C, C++ and Java. Means like a starting point should be there, na, for execution. So that is void main. Now we will come to the topic of this video. JVM architect. So this is the JVM architect. First, once we'll create a file, it will go into the class file. It will be in a dot class format. Then it will become into the object. Okay. So this is the compilation state. As you can see here, this is the compilation state, and this one is the execution state. Now I have defined what is compilation and what is execution. It will check the rules here and it will generate the output. So once it convert from source code to byte code, then it will get into the class loader system. Class loader means it will load the class in this subsystem. It consists of 3 blocks, that is known as a loader, linker and initiator. So in this one we have 3 important blocks, that is loader, linker and initiator. Once the class file get into the class loader, it will get into the loader block. Then it will go into the linker. Loader, linker and initiator. After get loading and after checking all the rules, then it will go to the runtime data area. This is a very important block. This is called as a method area, or you can also say as a class area. The other name is class area. This is the heap area and this is the Java stack area. This is PC register block, and here is a native method area. It used for native methods. So the class file will get loaded in the method area, in the runtime data area. Then again void main will be loaded here, and the void main will pass the value to the Java stack area, and here the objects are created in the heap area. Okay, once it is completed this block, it will go into the execution state. The execution state is a combination of interpreter, JIT compiler. JIT means just in time, or garbage collector. Okay, this is also, and here it will go to the native method interface. If you have any libraries you are using, it will connect it here. All the libraries are present here. So from here it is connected to the operating system, and from it is connected to the hardware. So this is the main architecture of JVM. How the class get first compile in the compilation state, and from how it go into the execution stage, and from execution state how it will go to the class loader file and again the runtime data area, and from how it will go into the execution engine, from there to operating system and to hardware. Okay, so we'll define some more terms here. Now we will define what is virtual machine. It is a duplicate, high performance and independent copy of the machine. It's known as a virtual machine. The virtual machine for Java language is Java virtual machine. Okay, before knowing what is JVM, that is Java virtual machine, we will see first what is virtual machine. Virtual machine is a duplicate, high performance and independent copy of the machine is known as a virtual machine, and the one is the Java is a Java virtual machine. Okay, so this is the definition of Java virtual machine. Now, no memory is allocated at the compilation state because Java is known as a dynamic programming language. That's why memory is not allocated in the compilation state, whereas when the object is created, a memory is allocated. Now we'll see what is dynamic programming language. The language in which the memories are created and destroyed at the runtime is known as dynamic programming language. In compilation state, in Java in compilation state, memory is not created, whereas memories are created and destroyed at runtime. That's why it is known as a dynamic programming language. Now the class loader subsystem we will see. It will load the bytecode as I've seen, as I've just now said. This class loader subsystem, it will load the bytecode onto JVM. While the loader bytecode has three components: loader, linker, and initiator. Loader, what it will do, it will check the availability of the bytecode of the .class file. I will draw a diagram here. This is class loader subsystem. It is a collection of, it has three blocks: loader, linker, and initiator. Now what is loader? What loader can do? It will check the availability of the bytecode .class file in app folder or extension folder or bootstrap folder. It consists of three folders: app folder, extension folder, or bootstrap folder. So first it will check the availability of the bytecode and then it will link to the linker. Okay, now what linker will do, it will verify the bytecode it is correct or not. Once the bytecode is corrected, prepare the code and resolve back. Okay, and resolution will get back the code. So first it will check which folder it is present, and here what it will link, and it will verify the bytecode is correct or not. Okay, and now what initiator will do, it will initiate the process the code is assigned with initial values. Means initial values will be there in the program, so it will initiate the process, and from what it will do, it will go to the runtime area, runtime data area, and here is consist of 5 blocks. Okay, the first one is the method area, the second is the heap area, and the third is the Java stack area, and this is the PC register and native method stacks, or you can say native method area. So this is the block now. The first one is the method area, the second one is the heap area, the third one is the Java stack area, the fourth one is the PC register, the fifth one is native method area. So what method area will do, it will the memory block, so memory block where class code or class information is loaded. In this block, class code or class information is loaded in the method area, the class area. The heap area is a memory block where objects are created, in heap area where objects are created, and the Java stack area is a memory block where methods are executed, is known as, in Java stack area methods are executed. Here the void main will take place, and from here it will go to the methods. From here it will go to the Java stack, objects are created. Okay, so the complete void main method is copied onto the Java stack area to start the program for the execution. Now what is PC register? PC register is a full form of PC register is program counter register area, the memory block which has program counter and maintains the status of the running method in Java stack area is known as PC register. Now how many methods are running in the Java stack area, that many PCs are created. Okay, it is directly proportional Java stack area and PC register. How many methods are there running, and that many PC registers are created. And the last one is the native method area. The memory block which is loaded with the native method is known as native method area. Example C and C++. Okay, now we will go to the execution engine. The execution is presented here, this one. It is a combination of just-in-time, garbage collector and all those things. So we will see about that topic now. Execution engine. Execution engine will contains two translators, interpreter and JIT compiler. Compiler is what? It will translate whole program at a time, and interpreter is what? It will translate line by line. Okay, they are both present in the execution engine. Okay, it is there only in Java virtual machine. It is not present in C and C++. Okay, and execution engine component is controlled by interpreter. These components are controlled by interpreter. Because of this reason, Java is interpret language and accept the request in the middle of the execution, which is suitable for network app development. It can accept the command or request in the middle of execution. And the third most important point is interpreter will execute the normal instruction of the application. Okay, and the repetitive instruction will be executed by JIT compiler. If any repeated instructions are there, it will done by the JIT compiler, which improves the performance of the application. The repetitive blocks which are selected and executed by the JIT compiler are known as hotspot. These hotspots are identified by the profile component of the execution engine. The process of identified is known as the adaptive optimization process. Okay, the repetitive blocks. First, what JIT will do, if any repetitive instructions are there, JIT will do that one, and with using that one we can increase the performance of the program. And the repetitive blocks which are selected and executed by the JIT compiler are known as hotspots. Okay, repetitive instructions are done by JIT compiler, and that is known as the hotspots. And these hotspots are identify the profile components of the execution engine. Okay, are also known as the adaptive optimization process. So we have seen just now the JVM architecture. What is JVM? Java virtual machine. What is a virtual machine? A virtual machine is a duplicate, high performance and independent copy of the system. And how it is divided into a compilation state and execution state. A compilation state where a source code is converted into a byte code, and in execution state where a byte code is loaded and the class file is loaded here. Okay, in the class loader subsystem where it has three blocks: loader, linker and initiator. First it will check the file in the app folder, execution folder and bootstrap folder, and then it will get to the linker, and the initiator will initiate with the initial values, and from it will go to the runtime data area. This block, it consists of 5 important blocks: method area, heap area, Java stack area, PC register and native method stacks. Method area is also known as a class area. Heap is also known as the object area, you can say, and this is Java stack area. First the program is loaded in the method area, and from the methods will take place executed in the Java stack area, and the objects are created in the heap area. PC registers are how many methods are created, that many PC registers are created. It will give the track record, of the methods. And the native method stacks are used in the C and C++. Once it is done, it will go into the execution engine. Execution engine consists of interpreter, JIT compiler, and garbage collector. Okay, what interpreter will do, it will do a line by line execution, line by line translation, whereas JIT compiler will do just in time. It will translate whole in a single time. And what interpreter will do, it will do line by line translation. Okay, so this is how it is. Complete program it will do, and here it will do line by line. And if the same repeated steps are there, what it will do, it will give it to the JIT compiler, and what JIT will do, it will execute it in as a whole program at a single time. So it will increase the performance of the program, okay, of the application. It will increase the performance of the application, and for doing that one, we'll name it as a hotspot. Are the selected and executed by the repetitive blocks are known as a hotspot. Now these hotspot are identify the profile components of the execution. We have some profile components in the execution engine, and they identified them as an adaptive optimization process. Okay, I hope you understand this JVM architect. If you have any doubts, please do comment. Please like my video, share and subscribe, and thanks for watching.